Hi, good afternoon. Thanks for making it to the session. And hopefully this is something that's at top of mind for a lot of you as you're building out GenAI applications with strong data foundations grounded in the context of your internal proprietary valuable data. So let me introduce e6data. Before that, my name is Vishnu. I'm the CEO of e6data. And we're trying to share how we believe there is a convergence happening between the world of SQL or query and search, which is really a quest for some information, and how they overlap and converge into the same flow, right? So we're trying to show you both a conceptual view as well as a demo of how you can combine the world of vector search as well as the richness and expressiveness of SQL, which we're all very familiar with, in the context of some of what you've already heard from keynotes earlier today, like SageMaker Lakehouse, which sort of is built on S3 and Iceberg and so on the powerful sort of data lakehouse as well as GenAI stack that AWS provides. So let me first start by introducing e6data. Right? e6data is built with the vision that there's an explosion in demand for compute, for data analytics and AI, and often the pace of growth of compute spend outpaces adoption and ROI, which is where a lot of top of mind concerns come in, and there's a lot of talk about cost savings, ROI linkage, etc. And as you all know, compute is at the heart of that sort of increase in spend, and we believe that for the full potential of analytics and AI to be achieved, you really need to adopt fearlessly, for which you need really cost-efficient, powerful, high functionality compute. That's where e6data comes in. So there's two things that we broadly offer today. One is a compute engine for all forms of querying, scheduled, interactive, data apps, and so on. So that's the block on the right. And compute to get data in from source into a queryable form in your Lakehouse foundation in seconds as opposed to minutes or hours, right? So that's at a high level. But with all the excitement, etc., around GenAI, what this is really doing is reducing the bar, right? Like for somebody to not have to be so technical and domain specific, but to still be able to engage with data. But what that also opens up is a bunch of problems, right? Like you may have all varieties of queries being generated for which we build guardrails, right? We protect your infrastructure from bad queries, harmful queries. We build governance to make sure that the right folks can access the right data. There's no unauthorized access patterns. And then we build the things that you've been excited about today, natural language to SQL, assistants, right? On top of and along with the AWS native offerings, but tailored to large-scale enterprise contexts where you have thousands or tens of thousands of tables, complex schemas. So we solve the accuracy problem there. So today, this talk will really focus on the querying engine, that is the compute engine for querying, and how vector search sort of fits in. You'll notice that the foundations for this entire stack, so we are the compute layer. Your data, we assume, is in either SageMaker Lakehouse, which is Iceberg, or open self-hosted Iceberg, or Delta Lake, for example, or any other open format. AWS's Glue catalog, Hive, any other catalog of your choice. We assume data could be in S3, and you have access to a bunch of other building blocks from AWS. Right, so this is a couple of companies that use us at scale, just a couple of examples to give you an idea of what a better compute engine can do. Individual use cases at scale, customers have realized several millions in savings on an annualized basis, while also achieving higher query performance and any level of concurrency. So let's talk vector search and the broader context that it fits in, right? Like I think for me, the most exciting part about this was, when we think of it, the richest information today, or rather like a few years ago, was never queryable, it was never searchable. It was things like video, audio, documents, text, and so on. Whereas, structured data was always queryable. Suddenly, this 90% or 95% of data that was never, you were never able to build intelligence or insights or ask questions of it, you can suddenly action, right? Like you can actually understand, right? And that's because embedding models and vector search has changed that. This has suddenly opened up a bunch of new possibilities. I'm sure all of you have experimented with and productionized different RAG workflows, both for internal use as well as customer-facing applications, and have got some learnings in terms of what works well, what doesn't. Other very revenue-generating use cases include catalog search to help customers search with natural language intent and still give them accurate results from your product catalogs, recommendation engines, fraud detection systems that need to work with extremely high relevance. So these are all just some applications of vector search in an enterprise context. Right, so broadly, the way I see it, there are two problems with vector search in an enterprise workflow today. One is where vector search is done, and second, how it is done, right? And this is in the context of an enterprise application, let's say. Let's look at where it is done, right? So the two boxes on the right there. You could do vector search today. Every operational database supports vector search, so it's not novel or new in that sense, right? But the whole point with central platforms like data lakehouses is that it's the single home for all your data. It's a single central home for all your data, right? The speakers from AWS earlier in the day talked about how they're investing heavily in zero ETL capabilities, such that any internal or external source can be easily synced into an Iceberg-based data lake in SageMaker Lakehouse, right? But OLTP databases are your upstream data. They hold a very thin slice of your overall picture, right? Like one data source only. So that's one problem there. The second is you have a class of downstream data sources or databases which are specialized vector databases, where you have to decide what data of relevance you load in, right? But as soon as you've done a vector search, you need to correlate it with all your other data, which lives somewhere else. So that's my problem with where vector search is done today. We think it should be done in the central. It's most valuable if done in the central home for all your data, which is your lakehouse, right? The next is how is vector search done today, right? And here is where, I think we are realizing, as a lot of us have experimented with vector search in real-world applications, that accuracy matters. So the ANN in most existing vector search methods is approximate nearest neighbor search. The whole point of grounding this in your internal proprietary enterprise data is to get accuracy or exactness. So this is one area I think that could be very exciting, right? And obviously, you don't want to have multiple hops of data. You want to combine it in a single sort of query flow, which is sort of where we focused as we built this. So just think of this as some sort of an internal system or a HR management system, right? This is something you're all very familiar with, everyone understands. And one operation there is a vector search or a similarity search operation, right? So if you're looking for everybody that's looked for concerns around no flexibility with respect to a work-life balance, right? So they may express this in n number of ways, but a text search would not catch this, right? You would have to look for exactly those words for a text search to work. You'll also notice that it is just another operation in a larger SQL flow where you have aggregations, filters, joins potentially. Similarly, if you're looking through your CRM or you're helping your customers look through your SaaS application and you're helping them mine for which users can I move from the basic tier to the enterprise tier, right? Here the search is looking for enterprise plan, but the user may have searched for, do you have higher features? Do you have this capability? Or is there a higher tier? Text search would never catch this, right? So again, vector search with the wrapped in a larger SQL context can be really powerful in what you deliver as a new revenue-generating use case. Similarly, again, if you're building fraud detection applications and so on, these are all areas where vector search could really sort of play a role. So let's now come from vector search to Lakehouse, which is sort of, again, what I said, right? Like, so some of the largest companies in the world on AWS build on lakehouses, right? So beyond a certain scale, it just becomes the natural architecture that unifies analytics as well as AI, operating off of a single platform of data, right? A single central data platform. You centralize it, you ensure quality, you ensure discoverability, you enforce entitlements and governance from that one location. Right, and one of the things that we were most excited about in December at reInvent was the announcement of SageMaker Unified Studio, where you can see that everything in AWS is now built on that foundation of Lakehouse, right? Like Iceberg tables and S3, which we're like super excited at. So this is a little bit about how we think the application flow or like the architecture could look. Right, so that block there is the e6data compute engine. So it'll do both SQL as well as exact vector search. And it's connected to your applications, whether it's a catalog search from your e-commerce site or if it's a document search for your internal facing applications. It could be the consumer of a RAG-based flow, right, like an LLM in this case, a recommendation system, whatever other system that you're building, right? So, and then all the way at the other end, you have your data in S3, structured as well as unstructured data that an engine like E6 is connected to. And remember, this is all in your S3, in your VPC, so no data ever moves. Right, so when obviously data, unstructured data of interest is made available, we would leverage the capabilities of Bedrock to generate embeddings. That is the act of taking your unstructured data and representing it in a multidimensional vector space. And where are those vectors stored? Also in your S3, right? So your data never moves, right? So that's one part of the equation. And then, of course, when a query comes in with combining SQL as well as similarity search operations, we execute the structured part of the query on your tables in S3 and the unstructured part, which is the similarity search or semantic search, against the embeddings that are there against that data. So, you know, this is like powerful hybrid exact vector search on all of your data, structured plus unstructured. So I'll stop here. I'll actually let my co-founder, who actually built a lot of this, to describe a couple of demos that walk you through this capability.
Yeah, so today we're kind of going to be, demoing how we showcase vector search against a reviews table, which typically has a lot of, data around reviews on products, which is, about certain reviews which have sentiments around good and bad things about it, right? So here we are typically looking for a review which is semantically similar to amazing product with timely delivery of sorts, right? And when you can see the relevance of your search being very close to what we actually are looking at. And what we've typically done is equivalent to searching for the 10 nearest neighbors to this particular input text of sorts. Now, what you can do in e6data is also kind of create vectors across different tables. For example, in this particular table, I've created it for the item description. And what I'm then doing is that I'm going to be embedding this vector search operation in a larger and more complex query operation that I want to do. And this is being done on a 1 terabyte TPCDS data set of sorts, right? So this kind of shows how you can actually unify, vector searches with a lot of complex operations that you kind of want to do on your data lake, and all of this is, stored in S3. Right. So this is the vector search operation which we've actually embedded into the SQL query as a subquery in the entire system. All of these vectors that you can kind of sing are all stored again in S3, like Vishnu said before. So, let me just passing it back to Vishnu. Vishnu?
Yeah, so that was, that was a quick run through of how we combine the two worlds of structured and unstructured data in something that all your teams are familiar with, like SQL, and do it directly on S3 and Lakehouse. So we also have a booth in the main area. Feel free to come by and check this out in detail. We can walk you through how we built it, some of the exciting use cases that are being enabled. Thank you so much again for your attention.